Hello, Integrated Math 1. Welcome to lesson E.1-2, actually. It's going to be a little bit of a longer one today since it is for a block period. But if you have your book handy, we are on page 12. So just to start off, just a little bit of discussion here. You can see I have a lovely little graphic up here. Some friends want to see a movie that is showing at two different theaters in town. You can see Theater A is $14.50 per ticket, $5.75 for popcorn. Theater B is $13 per ticket, and of course, $6.75 for popcorn. They want to see a movie that's showing at these two different theaters. They plan to share 3 tubs of popcorn during the movie. So, which movie theater should the friends choose and why? Just things for discussion. For what situation would the total cost at each theater be exactly the same, right? And explain why that is. And see, there are different methods to solving this problem. Which do you think is best and why? Go ahead and hit pause. Just have some thoughts on this, have a little discussion about this, and then hit play to keep going. So my thinking on this is, which movie theater should they choose? Well, that depends on how many people are going, right? That depends on how many people are going. We know they're sharing 3 tubs of popcorn each. Let me grab my pen here. We know they're sharing 3 tubs of popcorn each. So if I did 3 times 575, that's why I have a calculator. I know that the popcorn alone is going to cost them $17.50 at this theater, whereas at theater B, again, 3 tubs of popcorn times 6.75. At this theater, it's going to cost them $20.75. The only thing is, theater B is cheaper to get in. So it really depends on how many people are going, right? That's what it depends on, how many people are going. Because while the popcorn's more expensive at theater B, the ticket price is cheaper at theater A. So for what situation would the total cost at each theater be exactly the same? Well, I don't know. How many people, and I'm going to just say people is X. So 1450 times X plus the popcorn of 1750. When would that equal theater B, which would be $13 per person, so 13X, plus my $20.75 in popcorn. And if we solved this, we could figure that out, right? If we solve this, we work this out. If I subtracted 13X on both sides, and I got $1.50X. And then if I subtracted my 1750, so 20, and that's 20.25, not 75. Sorry, I wrote it down wrong. So if we did $20.25 minus 1750, so the difference in popcorn prices is $2.75. Divide that by $1.50. So it looks like I get like 1.8 and 3s going forever. So it looks like, I don't have an exact number here. It does look like if I have 2 people or more going, it's probably better to do theater B. If I'm just going by myself, theater A might be the better option. This is not the only way to solve the problem. I used an algebraic method to solve the problem, but you may have used a different one, and maybe you think that's better. I don't know. It's up to you. So I hope you've got your notes ready to go. We're solving equations with a variable on both sides. Again, this is lesson E.1-2, and we're going to see our variables showing up on both sides of the equations, just like on that little modeling problem we were talking about. So what is the value of x in the equations shown? This is example 1. Again, it is worked out in your book, but see if you want to tackle this. First thing I notice is like terms, right? I mean, that's the first thing I notice in an equation like this. I've got the same terms on both sides there. So I'm going to do 3x plus 4x. The other thing I notice is that there's some distribution I can do, right? So I'm going to go ahead and distribute that -2. So I'm going to do both of these. 3x and a plus 4x is, of course, 7x. -2 times x is -2x, and -2 times a -4 is a positive 8. Please watch your negatives. The other thing I want to do, I don't like that I have variables on both sides. So what I'm going to do is I'm going to collect my like terms on the same side of the equation. So I'm going to add 2x to both sides to get that over. And I'm also going to add 10 to both sides to undo that minus 10. And that way I have all of my like terms on the same side. And here's another way of writing it. So now I have my x's are all on one side and everybody without an x is on the other side. So 7x plus 2x is, of course, 9x. 8 plus 9 plus 10 is 27. And now I'm just going to divide by 9, and I find out that x is 3. Hooray! But wait, there's more. What is the value of n in the equation shown? All right, well, there's a couple different ways of managing this. I hate when we have something like dangling like this, though. So you know what? I'm going to start off, I'm just going to start off by adding 7 to both sides, and that way this will cancel out. And so I just have 1/2 n minus 4 equals negative 2n plus 13. I hate that 1/2, but I can undo a 1/2 by multiplying by 2, right? That would undo it. So I'm going to multiply each side by 2. So I'm going to multiply this side by 2 to make these go away. But I'm also going to multiply this by 2, which does mean I have to distribute here, and that's okay. So these 2's cancel out, which is why we did it. So I have n minus 4. And then 2 times a negative 2n is negative 4n. 2 times 13 is 26. Again, I have variables on both sides. So I'm going to collect my like terms on the same side of the equation. So I'm going to add my 4n to get rid of that and put it on the other side. But I'm also going to add 4 to collect it over on this side. And you'll see what I mean here. There we go. That's prettier. 1n plus 4n, of course, gives me 5n, and 26 plus 4 gives me 30. And now it's easy. If I divide both sides by 5, I find out that n is 6. Hooray. So you get the idea. If you have variables on both sides, so what? Move it to the other side. Use your inverse operations to move it to the other side so that you can collect all of your like terms on the same side. So I would like you to try these out. Number 1A and B over on page 12 in your book there, also of course on my screen. Go ahead and hit pause, work your way through these two problems, and then hit play when you're ready to check your work. So for me personally, the first thing I did on part A is I just distributed like crazy. I not only distributed there, I distributed over here. I was like, let's just get rid of all the parentheses, people. So 100 times z is 100z. 100 times negative 0.2 is a negative 20. Negative 10 times 5z is a negative 50z. And negative 10 times 0.8 is a negative 8. Sorry, I've been cast into darkness again. There we go. Better. And I want to collect all of my terms on the same side, right? I want to collect my like terms on the same side. So I'm going to add 50 to move it to the other side. I'm going to add 20 to move it to that side. 100z plus 50z is, of course, 150z, and negative 8 plus 20 is 12. I do need to divide both sides by 150, and that does mean I get a decimal, but that's okay. I mean, we had decimals at the start, so it's no big deal if we have a decimal in the end, which in this case will be 0.08. Yay. Now, let's talk about this next problem. This next problem, I hate the 5/8. I hate the 5/8. So you know what I did is I multiplied by 8. But that meant I had to multiply everybody by 8. We did this the other day. Again, not the only way of doing this, but it's the way I approached it. I suppose I could have distributed the 5/8, but I don't like multiplying with fractions, so I'm just going to use this method because that way, whoa, my pen, that way these 8s will cancel out. And I just have 5 times 16d plus 24. 8 times 6 is, of course, 48, and 8 times 1 is 8. And this looks better. I mean, it's still a hot mess, I know, but it looks better. I think next I'm going to distribute, and I'm going to distribute this guy, but I also need to distribute that guy. So I'm doing all kinds of distribution. So 5 times 16d is 80d. 5 times 24 is 120. 48 times d is 48d. And 48 times a negative 1 is a negative 48. I do have d's on both sides. I have variables on both sides. So I'm going to collect everybody on the same side. I'm going to go ahead and subtract. That is a positive 48D, so I'm going to subtract 48D to move it to the other side. I'm going to subtract that 120 to move it to that side. And then it's a matter of cleanup. Thank goodness I have a calculator. 80D minus 48D gives me 32D. And if I use my calculator correctly, negative 48 plus 8 minus 120 is a negative 160. If I divide both sides by 32, I find out that D is a negative 5. Yay. So it got a little intense. But that's okay. Nothing we can't handle. Nothing we can't handle. We can do this. I got a few more for you though, because I'm going to start throwing a few tricks your way. All right. I'm going to start throwing a few tricks your way because you guys have solved equations before. That's not new. So what happened? We have some special circumstances here. So on page 13, example 2, if we're looking at part A, what is the value of x in 4x plus 6 equals 2 times 2x plus 3? So you know what? I'm just going to solve for x. I'm just going to solve for x. So we have 4x plus 6 equals, let's go ahead and distribute, right? Always a good plan. I'm going to go ahead and distribute and distribute. So that means 2 times 2x is 4x, 2 times 3 is 6. I don't like that I have x's on both sides, so I'm going to move the x over. I'm going to go ahead and subtract 4x. I'll do it to both sides. So now I have 4x minus 4x, 4x minus 4x. I guess I didn't need to draw that. I have it here. Uh-oh. Wait, what happened? All of my x's just canceled out, didn't they? Right? 4x minus 4x is 0. 4x minus 4x is 0. So I have 6 equals 6. So what's happening here? We didn't do anything wrong. We solved the problem right. We used distributive property. We tried to collect our variables on one side, but my variables completely disappeared. Now, I'm looking at this and it says 6 equals 6. And of course, 6 equals 6. So that means that something's going on here, right? Because 6 equals 6 is always true. Like, I know 6 equals 6. It's always true. It's equivalent to the original equation. That means the equation is true for every value of x. When this happens, because 6 equals 6 is always, always true, it means that it doesn't matter what you plug in for x. It's always going to be true. So the equation is true for all values of x. And an equation that is true for all values of the variable is what we call an identity, right? Since this equation is true for all values of the variable, it is sometimes referred to as having infinitely many solutions. So yeah, 6 always equals 6. Of course it does. That's an identity, all right? It's always true. And that means we have infinitely many solutions. Let's look at a slightly different situation though. Let's look at this next one on part B. What is the value of x in 6x minus 5 equals 2 times 3x plus 4? So again, I'm going to solve for x. Again, just like I know how to do, I'm going to go ahead and I will distribute my 2, right? Use my distributive property. 2 times 3x is 6x. 2 times 4 is 8. Again, I'm going to collect my variables on one side. So I'm going to subtract 6x from both sides. Oh, this happened again. 6x minus 6x is nothing. 6x minus 6x is 0. It's nothing. And now I have negative 5 equals 8. But that's not true, right? Negative 5 doesn't equal 8. Negative 5 does not equal 8. That's not true. That's never going to be true, right? Negative 5 is never going to equal 8. But this tells us something. There is no value of x that makes the equation true. Nothing can save this equation, guys. Nothing, all right? It's never going to be true. So that means the equation has no solution. Yeah. So if you get something like 6 equals 6, that's always true. It's an identity, and that means it has infinitely many solutions. If we get something like this one, where we had negative 5 equals 8, we know that's not true. And so there's no solution, and it's definitely not an identity. So I would like you to go ahead and solve both of these equations. So I'd like you to solve these equations. Is the equation an identity? And I just want you to explain why it is or is not an identity. Go ahead, hit pause to solve both of these equations. Hit play when you're ready to check your work. All right, all right. First things first on this first equation, I'm going to distribute that negative. I know it seems weird, but it's important. So negative times 27 is a negative 27. Negative times negative t is a positive t. Great. I'm going to go ahead and subtract t from both sides just so I can gather both of my t's on one side of the equation. Oh, but t minus t is 0. So I end up with negative 27 equals negative 27. That equation is true. It's always true, right? I mean, negative 27 always equals negative 27. It's true for all values of t. So it is an identity with infinitely many solutions. Yay. For part B, again, I distributed. I was like, let's distribute. I need to distribute the 16, and I distributed the 96. There was a lot of distributing happening here. So 16 times 4 is 64. 16 minus 3m. 16 times 3, it's 48. Okay, so it's a negative 48m. Be careful here. 96 times negative m over 2, that actually means we have to cut our 96 in half. So half of 96 is 48, and a positive times a negative makes it a negative 48m. 96 times 1 is 96. Again, I don't like that I have my variable on both sides. So I'm going to go ahead and add 48m to both sides to kind of get them to gather up, except a negative 48m plus 48m cancels out, right? Negative 48 plus positive 48, those cancel out. I get 0. And I have 64 equals 96. That's not true, is it? 64 does not equal 96. We know this. 64 definitely does not equal 96. So fine, there's no value of m that makes the equation true. It has no solution, and it's definitely not an identity. Let's go to example 3 on page 14. Arabica coffee costs $28 per pound, and Robusta coffee costs $8.75 per pound. So Arabica coffee is expensive, right? It's expensive. So sometimes we like to mix it in with the other blend, right? Brings down the price a little bit. How many pounds of Arabica coffee, and I'm probably saying that wrong, sorry about that, must you mix with 3 pounds of Robusta coffee to make a blend that costs $15.50 per pound? Okay. I have got to organize myself. I've got to organize this information. Okay, so I have a table. I made a table. So it's like, okay, so Arabica coffee is $28 per pound times the number of pounds, which I don't know how many pounds it is, so I'm just going to say A. And so that means it's going to be 28A. I know I'm doing 3 pounds of the Robusta coffee. So 875 times my 3 pounds brings me to 2625. And I know that together, if I add those together, it should equal my coffee blend. And I know my coffee blend, I want it to be $15.50 per pound times the number of pounds, which is my Arabica coffee, which I don't know how much it is, plus 3, because I know that's the Robusta. And so I'll write it like this, 15.5 times A plus 3. So I know these two added together should equal my blend. So I'm going to write an equation to represent that, right? 28A plus 2625 equals 15.5 times A plus 3. Awesome. Oh, and now I just need to solve it. So I'm going to go ahead and distribute the 15.5. So that means I have 15.5A, 15.5 times 3 is 46.5. Awesome. I'm going to go ahead and gather my like terms on the same side. So I'm going to subtract my 15.5A to move it over there, and I'll subtract my 26.25 to move it over here. I will definitely grab a calculator. 28A minus 15.5A is 12.5A. 46.5 minus 26.5 is 20.5. And of course, oh, sorry, I'm dropping things. If I divide both sides by 12.5, I get 1.62. So you must mix 1.62 pounds of Arabica coffee with 3 pounds of the Robusta coffee to make a blend that costs $15.50 per pound. Awesome. It also means you're buying more than 4.5 pounds of coffee. That feels like a lot, but I guess if you're a big coffee drinker, it's not a big deal. I don't know. Why don't you go ahead, now that you've got this in your head, can you try out problem number 3, the try it problem number 3 on page 14. Go ahead, hit pause, work this out, hit play when you're ready to check your work. All right, so Arabica coffee still $28 per pound, Robusta still $8.75. We know that. But now we've changed a few things because now I'm doing $28 times however much Arabica coffee we're doing. But now I'm also doing $8.75 mixed. Oh, it's 5 pounds. So I need to multiply that by 5. And I want it to equal $12 per pound. So 12 times not A plus 3 this time, A plus 5, right? Pounds of Arabica coffee plus my pounds of Robusta coffee. So I know these two added together should equal this one right here. Awesome. There's my equation. And now I do need to solve, clean up, right? I need to multiply these, 8.75 times 5. I need to distribute my 12. So I end up 8.75 times 5 is 43.75. 12 times A is 12A. 12 times 5 is 60. Ooh, we need to gather our like terms on the same side, right? So let's subtract 12A to move it over. Let's subtract the 43.75 to move it over. Use my calculator. 28A minus 12A is 16A. 60 minus 43.75 is 16.25. When I divided, I got a long decimal, so I rounded it a little bit. So when I did 16.25 divided by 16, I got about 1.02. And again, it was a longer decimal than that, but I was just trying to round it. Let's go ahead and answer the question then. We've got our numbers here, so let's do this. You must mix approximately 1.02 pounds of Arabica coffee with 5 pounds of Robusta coffee to make a blend that costs $12 per pound. Yay. All right, we got another example. Example 4, also on page 14. So Cameron currently pays 95 cents per song with his current music service. So right now, the music service he's using, it's costing him 95 cents per song. A new music download service charges only 89 cents per song with a $12 joining fee. Should Cameron switch to the new service? Well, kind of depends on how many songs, right? So let's see if we can set up an equation to represent when the cost for the number of songs is the same for both services, all right? We're going to use S for our number of songs. We'll use that for a variable. I usually like to use an X, but whatever. So I want to see when my new music service equals Cameron's current music service. Well, all right then. I know that Cameron's current music service, and sorry that the colors went a little off here. I know Cameron's current music service is 95 cents per song, so 0.95 times S. I know the new service is 0.89 times S plus that $12 fee. And sorry, the colors, like I said, went a little bit off there. So here's my new music service, 89 cents per song plus the $12 joining fee. And I want to know when that's equal to what the current service is, which is 95 cents per song. So let's solve it, right? So we're going to solve the equation to find the same number of songs at which the cost for each option will be the same. So great. I'm going to go ahead and subtract 0.89S from both sides, gather up my like terms on the same side. So I'll subtract 0.89S on both sides. Thank goodness I have a calculator. Turns out that's 0.06S. Ooh, if I divide both sides by 0.06, of course, 12 divided by 0.06, thank you, Mr. Calculator, is 200. So the cost of the two options will be the same for 200 songs. So if he's downloading 200 songs per month, hey, you know what? It doesn't matter which one he's using. But if Cameron plans to purchase more than 200 songs per month, he should be switching, or more than 200 songs. I guess it's not even per month. If he's planning on purchasing more than 200 songs, he should switch to the new service because it will cost less than his original service, than his current service. But only if he's doing more than 200 songs. So Cameron does a little bit of research, and I'd like you to try this problem. Number 4 on page 15. It did kind of bleed over to the next page. So Cameron still is paying 95 cents per song with his current music service. That hasn't changed. But Cameron's friend tells him of another service that has a $15 joining fee but charges 80 cents per song. At what number of songs does this new service become a less expensive option than Cameron's current service? Go ahead, hit pause to work this out, hit play when you're ready to check your work. All right, so I thought, all right, well, 80, and I'm going to go ahead and use an S again for song. So 80 per song, so 0.80 S plus the $15 joining fee equals that 0.95 S. I'm going to go ahead and gather my variables on the same side of the equation. So that's a positive 0.80 S. I'm going to subtract 0.80 S from both sides. So these will cancel out. And 0.95S minus 0.80S is 0.15S. If I divide both sides by 0.15, 15 divided by 0.15 gives me 100. So if Cameron purchases more than 100 songs, the new service is going to be a less expensive option. Yeah. As always, guys, I hope you found this helpful. I hope you found it useful. If you got questions or concerns, come see me. I'm around at lunch. I'm around during office hours. I'm around during class. That's true too. And in the meantime, I'll see you guys later. Bye.